Alright, so today we're going to be doing our Chapter 12 review. As soon as this is posted, I'll also post your test so you can complete that. It'll either be posted today or tomorrow, which is Friday, depending on when you're watching this. So we're just going to go ahead and review some problems before we take our test. So we're going to start with just writing terms given a formula. Here we have an explicit formula. A sub n equals 3n squared. We want to write the first four terms. So since it's explicit, we're going to plug in 1 for n first. So a1, if we excuse me, plug in 1, we're going to get an answer of 3. And if we plug in 2 for n, we'll find a sub 2. So 2 squared would be 9. 9 times 3 is 27. Then for a3, we would plug in 3. 3 squared is 9. Well, looks like I messed that up. So that was 27. Let's go over to this guy and erase all of it. All right, so let's just start that over. So this was 3. A sub 2. So 2 squared is 4. 4 times 3 is 12. Okay, now I can do simple math. Now we plug in 3. 3 squared is 9 times 3 is 27. And then a4. We'd plug in 4. 4 squared is going to be 16 times 3 is 48. So those will be our first four terms. All right, same direction, but here we have a recursive formula where we got the sub n minus 1 here. Excuse me. So we're given our first term as 3. Now with the recursive formula, when we find the second term, we're actually plugging in the first term in for this whole thing here, the a sub n minus 1. So we go 2 times 3, which is 6, plus 3 is 9. And then to get the next term, we would take 2 times the term before, so 9, which is 18, plus 3 gives us 21. And then if we want a4, plug in 4, or sorry, not plug in 4, excuse me, we plug in 21 since it's recursive. 2 times 21 is 42, plus 3 would be 45. Here you want to write an explicit formula. So we know it's going to be a sub n equals. Now if you notice, we're subtracting by 6 every time. It's arithmetic, right? So we're going to be subtracting 6 n amount of times. Well, we want our first term to be 15. So it's kind of like going backwards. We want to start at 21, kind of adding 6 there, because if we plug in 1, we get 21 minus 6, that's 15. Now if we plug in 2, we get 21 minus 12, that's 9. Plug in 3, get 21 minus 18, that's 3, and so on. All right, here we're writing a recursive formula again. So again, a sub n equals. If you notice, we're multiplying by a negative 3 every time. So if we keep multiplying by the same number repeatedly, that's exponential. Okay, we're multiplying the same number every time. So we're going to need something times negative 3 to the, and we're going to actually use n minus 1. Because if we just plug in negative 3 to the 1, well, that would be negative 3, and it's going to be a pain in the butt to get negative 2 for our first term. But here if I plug in 1, I would get negative 3 to the 0, which is, well, 1. So since I want a negative 2 to be my first term, I'm going to start with a negative 2 out front. So negative 2 times negative 3 to the n minus 1 power. So just keep thinking to make sure the next ones work. If we plug in 2, we would have negative 3 to the first, which would be negative 3 times negative 2 gets me negative 6, or gets me 6. If I plug in 3, well, negative 3 to the would be second, would be 9 times negative 2 is 18, and so on. So that would be your explicit formula there. All right, so when we're supposed to expand and evaluate, okay, we're finding a sum, okay? Now notice we're starting at the third term going up to the sixth. So if I want the third term, so that would be, so we'll just say A3. Okay, we plug in 3 in for K, so 25 minus 3 squared is 9, would give us 16. And we need the fourth term, which would be 25 minus 16, which is 9. The fifth term, which would be plugging in 5, we would get 0. And then if we plug in the sixth term, we'd get a negative 9. So that's so expanding it would be writing 16 plus 9 plus 0 plus negative 9. And then evaluate, we need the total. Well, that total would be 16. Again, we stopped at the sixth term because it told us to here, terms 3 through 6. All right, now here you notice we go up to all the way to 40. So rather than doing this 40 times, here we can use our arithmetic sum equation, which says the sum of the first n terms is going to be a1 plus a sub n all over 2. And all that times n. So, trying to figure out a formula, a sub 1. That means plug in the first term. So, we would plug in 1, 10 plus 5 would be 15. And so then we need to add a sub n. So that's plugging in 40. So 5 times 40 is 200 plus 10 is going to be 210 all over 2 times our n, which is 40. And let's see, plug that in my calculator here so I don't give you the wrong answer. So it looks like we got 225 divided by 2, and then that times 40, and we're going to get an answer of 4,500. And I'm going to be putting a time limit on this test, so you really don't want to be adding 40 terms, plus then you got a greater chance of making a mistake. All right, here another one. We got 52 terms of k, so that's 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 all the way to 52. Well, for this one we have our linear sum formula, which for a linear 1k is n times n plus 1 all over 2. So our n is 52. So we're going to have 52 times 53 all over 2. And that's going to equal 1,378. So there's your answer there. Again, pretty simple as long as you know which formula to use. Okay, same thing, but now it's quadratic. So we got to use the quadratic formula here, which is n times n plus 1 times 2n plus 1 all over 6. So here our n is going to be 23. So 23 times 23 plus 1, which is 24, times 23 times 2, so 46 plus 1 is 47 all over 6. And 23 times 24 times 47 divided by 6 is 4,324. So that's that one. All right, next we got to rewrite using summation notation. So remember, summation notation looks like this. We'll start at 1 for all of these. We have 1, 2, 3, 4, 5 terms. And now we got to write the equation. Well, looks like we got a bunch of perfect squares here. Right? But we got 2 squared, 3 squared, 4 squared, 5 squared, 6 squared. Well, we don't want to do just regular k squared because we'd be plugging in 1 first. So that won't work. But if we want to plug in 2 first, we could call it k plus 1 squared. That would start us at 4 because we plug in 1, 2 squared is 4. And then so on. You plug in 2 to get the second term, 3 squared is 9, and so on. So this would be kind of the answer that we're looking for. However, another way you could do it would be to start at 2. And then you could go k squared, right? Because then it would tell you to start with 2, then 3, then 4, then 5. But we need 36, so I suppose we're going to have to do something about that. Switch my eraser. We would have to go up to the 6th term. So this would be another way of doing it. Okay? Or, again, just use the k plus 1. All right, find the 58th term. So you could sit here and add numbers till we get to the 58th term. Or, since this is an arithmetic sequence, notice we're subtracting by 9 every time. We can use our general arithmetic formula, which is a sub n equals a1 plus n minus 1 times d. So we want the 58th term. So we take a1, which is 72, plus n, so 58, minus 1. D is the difference, so negative 9. And then we can calculate it up. So if we take 72 and we add that to 57 times negative 9, I'm going to get negative 441 for an answer here. So that would be your A58. All right, given 2 problems in an arithmetic sequence, so we're still using our formula a sub n equals a1 plus n minus 1 times d. Now we have the 10th and the 27th term. We want to find the 16th. So let's switch colors here. First, we got to find d. So for a sub n, we're going to use the last known term, which is negative 11, equals, we don't know a1, but the first term that we know of is a10. So this is going to be 91 plus, now n is whatever number term this is. So since we used a negative 11 here, that was the 27th term. And then 91 was our 10th term. So minus 10. And then we got to solve for d. So negative 11 equals 91 plus 17 times d. We subtract 91. So that would be negative 102. Just doing some math on my calculator here. Oops, don't want to do that. So that would equal 17D.